thank you for being here in the very last slot of the very last day. Appreciate it. And now we're going to talk about building a private CI/CD pipeline with Java and Docker. My name is Baruch. I'm developer advocate with JFrog at JBaruch on Twitter and pretty much everywhere else. This is basically what I do in my job. And today we're going to talk about Docker, so that usually requires a lot of both, actually. Before we start, just to calibrate a little bit the level of my talk, let's do some fun polling. So I'll show you some questions, and you just keep your hand up until it's not relevant to you anymore, okay? So let's try that. Who heard about Docker? Everybody? All right, now keep your hands up until it's not relevant to you anymore. Who can do the tutorial? All the hands are still up. Who played with it a little bit in their job, mainly, for tried some stuff? Okay, most of the hands are still up. And how many took it to production? You can take down the heads now. Yeah. Yeah, that's okay. That's okay. Any hands still up in production? 1, 2. No, he's just filming. 2, 3. Okay. So that's a normal picture. It wasn't really a poll because I knew exactly the results. So it's kind of a manipulation. And in this talk, we'll try to answer this question: why you don't take Docker in production, and give you some advices that will build up your confidence in Docker, so you actually will be able to do that. Since all of you know about Docker and all of you played with it and does the tutorial and everything, I will happily skip the next slides that are explaining what Docker is, and we will go right here. That's the answer to my previous question, right? So the problem with Docker, and this is what we hear from a lot of our friends, users, customers, etc., is that it adds another level of this opaque, not transparent level that we are not sure what's going on, right? So what I'm going to talk with you about today is kind of building the integrity and the trust you need to be able to run Docker safely in production. Now, the reason I'm speaking about it being a developer advocate is JFrog and not working with at Docker is because I think that we as a company have a very long-standing relationship with Docker, and the picture depicts it. And if you aren't sure what's going on, is the frog is hugging the whale, right? Just to make sure that this is what's happening here. It's a hug. We love Docker, right? And the reason we are dealing with Docker is that. So this is Solomon Hykes, the creator of Docker, standing on stage of DockerCon 2015 in San Francisco and asking the audience the same question. That's another manipulation of mine. Let's play it again. So what he means by this question, who's using Docker is nothing else, is, you know, think about the company and your software process. Do you use any other technologies except of Docker? So that's kind of the question. So who uses Docker and nothing else? No one. That's perfect with this small audience. It was the exact same result, of course, at DockerCon with thousands of people in the keynote, just because using Docker and nothing else doesn't make any sense. Docker, the whole container analogy works very well here because in the real world, no one will have a company that only ships empty containers back and forth. It doesn't make any sense. There is something in it. And the same with Docker. There is something in it. We are at DevOps, so probably most of you put your Java into Docker. Am I right? Java? Yeah, OK. And the rest of you put other things like maybe NPM, JavaScript, .NET, or Python, or I don't know what. Doesn't really matter. You have something in it. And what we do as JFrog is we manage those binaries, those Docker images, together with other technologies to provide you with the link between them that you need. But that's a corporate plug that I won't do now. What we're going to speak about now is patterns that apply to Docker images as they apply to other things. So we are all software engineers, software architects. When we have a new technology, this is what we do. We look for all technologies that do something pretty much similar, and then we check whether we need to adopt the best practices, the patterns that we have from there. And the continuous integration pipelines that we build with our software are exactly the same for years now, right? It's something that we do for decades, and this is more or less what we know how to build, right? We know to take the builds and to run them through this promotion pyramid when on each and every level we have less and less builds survive, and we take them through more and more significant testing, right? So we start with using tests, with using unit tests. All of our code is being checked. Whatever survived the unit test passed to the next level, the integration tests, and then to staging, manual QA, et cetera, et cetera. That's exactly the same picture on its side, and that's a diagram that I love a lot from Michael Huterman and his book Agile ILM. What you see here is the exact same promotion pyramid when you take your artifacts and pass them through what Michael calls quality gates. And those are exactly the checks. And you promote them from one repository to another repository and all the way to production environment, and you do your checks on its way. Now, again, I really hope I didn't say anything new on the last two slides. We do it for years, we know exactly how to do it, so why the hell won't we do it with Docker? And the answer is Chuck Norris. Well, the answer is Docker build. Docker build is extremely powerful and easy build tool to manipulate and work with. And when you have such a tool, everything looks like nails, and what naturally we try to do is using Docker build instead of more or less everything. So instead of the promotion pipeline that I showed you in the previous slide, with Docker, a lot of the times, the natural tendency is doing that. Instead of promoting the artifacts that we build, we can just promote the build file and Docker build it on every step. That's a very natural tendency of ours, and it actually makes sense because it's very easy to promote a text file. It's as easy as tagging it differently or moving it between branches or something like that. We don't need any new tools. We don't need anything complicated. Promoting a text file is super easy. But the problem is that fast and cheap builds are not always the way to go. This is an image of a completely built and complete residential building in Shanghai, China that collapsed, hopefully before people moved in. I'm not sure we will ever know. Well, yeah. So that's the problem with building Docker again and again on every step of our continuous integration pipeline from scratch. I thought about creating this ridiculously broken and bad build file, and then I just went to the internet and I Googled like Docker build. The internet is full of those. GitHub, start repositories, like cloned repositories, popular stuff, all looks like that. And in this marvelous example, every line of this Docker file is trying to fetch a latest version of dependency, except of creating a directory and then running something, which is, of course, very bad. And now, just to remind you, all of you know Docker, so especially those who take it to production, and those guys should now stop me and say, what the hell is wrong with you? This is not how we write, right? We can fix all that. So let's start with fixing the base image reference, the from statement. How do we fix it? Versions, right? Someone said versions, of course. Let's fix it. Boom, fixed. Is it? Did we fix it now? Who thinks we didn't fix it? Why? Someone can update the tag, right? So the tags in Docker are not immutable. I can create a new image and retag it with the same tag. But why would I do that? We know the semantics of a release version. Ubuntu 14.04 should mean today exactly what it meant in April 14 when it was released. Is it? Is it the same image today? Why not? Security updates. Remember Heartbleed? Heartbleed was a lot of fun, wasn't it? We don't like to update our server software. We don't like to update our Ubuntu version. And in order to force us to get the security update to fix Heartbleed, Canonical releases security updates inside release versions. 14.04 today is not 14.04 in April 14. 3 years by now. How do we fix it? How do we make sure that the from image is absolutely always the same? What can we use? Latest is definitely not guarantees that it's always the same, the other way around. It guarantees that it's always new one. Huh? We'll get to that, thank you. And I didn't pay this gentleman. Fingerprinting. You know this guy? That's a checksum of a file. Now, the checksum of the file guarantees that it will always be the same file, right? Did we fix it? Looks like so. By the way, do you know which version of Ubuntu I'm using now? I think I just slapped on the keyboard and this is what it ends up with, right? This is very reliable, but completely useless. I have no idea what version of file do I use. So this aside, how about that? How we fix those? How we fix those? Anyone? Yes? Thank you very much. Of course, we can specify versions, and we should specify versions. Because we can put like the latest version of Python, or the version of Python that we know that is good, and the good version of Node.js. But how do we know that? Thanks to this gentleman, he knows how Debian apt-get works. He knows that he can nail down the versions. How about this guy? How reliable a repeatable build of mvn clean install is? Can we rely on that? I guess the answer will be, it depends, right? If you know your Maven very well, you can work hard and make sure that it always be the same. How about that? That looks reliable, right? I guess my point is you cannot rely on your Docker build script to emit the same image after each and every build. And you are in a very big danger of getting that. You run your Docker build in development and you get an image. You expect the same image to be in production, but it can be a completely different one, or even a slightly bit different one, but definitely not the one that we spoke about, right? So this is not the way to go. And we can take another pattern and get a lot of inspiration from it, and that's the immutable server pattern from the great Martin Fowler that say, do not change the servers in production. Instead, every time, create a new server and run it to production. And we take this idea of immutability to our Docker images as well, and we say, promote immutable and server and stable binaries all the way from development to production through those quality gates. Do exactly that. Build it once, and then promote, and here are our quality gates again, promote, promote, promote through quality gates. And you might say now, okay, this guy is clearly obsessed with gates. What's going on? Well, I do have good reason I have to say, because quality gates ensure that everything is exactly where it should be. When you have separate repositories, which are firewalled by environments that you need, you can guarantee that your production environment, Swarm, Kubernetes, Mesos, whatever you use, will only see and get access to the repository that you specified and to the images which are qualified to be in those stages. You guarantee that you won't end up with untested images being deployed to production. And again, this is not new. We do it with repositories in Maven all the time. We know exactly that our deployment tools, Chef, Puppet, Ensemble, Salt, whatever, if they only can access a production-ready repository of artifacts, it will always deploy production-ready artifacts to production, right? How hard can it be, and why I'm wasting your time on the last day on the conference? Well, because Docker. Docker makes this simple operation very, very difficult. And that's because of the limitations which are not exactly justified, just like this limitation was. And those limitations come from how the Docker tag file is built. And Docker tag syntax is built. And you can see here that the command of Docker tag receives a registry host as a part of the tag with a username and then a name and a tag, and the separators between those different tokens of Docker tags are forward slashes. The problem is that in this universe, forward slashes are already taken by some other very popular standard, the URL. So if you have a forward slash that separates between the registry host and the tag name, how the hell can you have multiple registries per host? You need to separate them with the context URL, but after the slash, boom, you already have the tag name. How can we support that? Docker dev, Docker QA, Docker staging, and Docker prod under the same host, when after the slash you are not allowed to put anything except of the tag name. So that's kind of the same, I would say, the same level of limitations which are here with us to stay, and we need to find a way to deal with them. And of course, the natural way of dealing with that is that. But after you have gone through this stage, the next one will be trying to find a workaround. And fairly enough, we do have a workaround in the shape of virtual hosts and or virtual ports. So what we can do is we can translate this syntax of registry host and tag name, and this is how the request looks like, pretty much the same, registry host and then the tag name. We can translate it into this URL that has the context name, the virtual repository name, and the tag name by using a URL rewrite techniques which are available in any modern HTTP server. So here's an example of nginx that does that. And what it basically said is when the request comes to port 5001, forward it to Docker dev. We will have the same for Docker staging, Docker prod, et cetera, and this is how we can have separate registries from the Docker point of view, pointing to the same artifact repository in the, I would say, normal artifact management point of view, right? So we will have that, and then we'll successfully tag our Docker images with whatever host this is going on with, port 5001, and it will successfully work. Now, the problem is, how do we promote? Promotion, as I remind you, would be moving the artifacts, Docker images, from registry to registry, taking them from development registry to staging to production. Will it require retagging? Depends on the tool that you use. If you just install multiple Docker registries in the same host and give them different virtual ports or physical ports, then yes, you need to download your artifact, retag it, and upload it again. Considering we are talking about huge files, Docker images are big, that might be not the optimal way. And here, a little bit more of shameless plug of JFrog Artifactory, although it can be, of course, accomplished by other tools as well, is the virtual repositories that we use. So here we have Artifactory repositories, which behave as normal Docker registries, and tools can access them by their virtual hosts and virtual posts, but the promotion here will be done behind the scenes, and retagging will be taken care for you automatically. So now when you want to move a Docker image from dev registry to staging registry to production registry, all you will do is issue a REST API request that will take it through those stages from one to another. And more so, you can group them into a virtual repository and then just expose a single registry that will show Docker images from multiple repositories as a single registry. And to give you an example how you put all that we learned to use, I will give you an example of a Docker system that we will build in the last, the 10 minutes that we left with. So let's first of all look at the container that we want to build eventually. And it will include three main parts. We will use a base image. Let's take CentOS for this example. And then we add a framework that our code will run with it. And in this example, it will be JDK 8 and JBoss Red Hat Wildfly on top of it. And then some WAR file. This example, again, it's a WAR file that runs some Couchbase application, but it's really just an example. So this is what we want to build, and we will need two different builds to create this container. And we will need two builds because that's exactly the number of different release cycles that we see here. And what I mean by different release cycles is how frequent we change the version of components inside. Obviously, we change the WAR file every time we have a new build, being it after each and every application commit. When we have a commit to our Git by our developers, the continuous integration runs, and it ends up with a new WAR file. That's not the story for those guys. We will update things like the version of our application server, the version of our JDK, and the version of our base image much less frequently. Maybe there is a new release of Java that we want to take. It's what, once in a couple of months. A new release of Wildfly, about the same. New release in CentOS, once a year, once a couple of years, right? So the release cycle of those two and the release cycle of the WAR file are completely different, and that's exactly why we need two builds. So first, let's talk about the framework build. The framework build, we take a verified base image, and by verified, I mean the one that we checked. We agreed that this version of CentOS is good for us. We will use that. And then we add system dependencies. And in system dependencies, in our example, are JDK and not Tomcat, Wildfly. And we take them from a trusted source as well, like your in-house repository. And then the most important part of all that is that we own the base image. And that's going back to the comment of this gentleman when we spoke about how can we make sure that we have no surprises every time we run Docker build and a version of CentOS somewhere in the wild is changed, is by owning your base image. When we own it, no surprises can be there. And that's the minimal framework build Docker file, right? It doesn't have any dependencies at all. All it takes ownership on some base image. So in our example, this takes an ownership on CentOS 7, and we will use this as our base image starting now. So we are 100% sure that no changes in CentOS 7 out there will affect our system anymore, right? So we own the base image. And application build is also very simple now. We use framework as our base. The Java build file runs, and then we add a single file to our base, whatever our Java build actually produced. And then we're done. So here's an example of how this build. So we use our own framework, and then we add a single file to our base, to our framework. And here, in this example, I take the WAR file from a release repository. And that's a debatable question. And the question is the life cycle of my Java WAR file can be verified, if my Java WAR file can be verified outside of the Docker image that I want to take? It means, can I take this WAR file through the promotion pipeline of its own, from development to release without packing it into Docker? The answer depends, of course, on your process. Sometimes it's yes, and then you will take it from the release, and sometimes it's no. You need to build your Docker image as soon as possible and test everything with the Docker image, and then, of course, you will take the WAR file not from the release repository, but from the development repository. That's up to you. And here are a couple of more questions. Why the hell do I take the latest version here? And those brackets release actually means take the latest release. Am I allowed to do that? Didn't we speak about not depending on the latest version? But this is mine, right? The WAR file ended up as a release in a release repository after a promotion pipeline. I can be sure 100% that whatever is in the release repository is good. And if I'm sure about that, I can safely take the latest one. And it's actually the same with the framework. Although we rely on latest, this is our latest. If you remember, we verified it, we built it, we own it, we can safely take the latest framework. It is as good as any previous one. And this trust that we build into both any version of framework that is released for us internally and any version of our application that is released for us internally allow us to do something cool, which is called the sandwich testing pattern. And that's another pattern that we talk about. The sandwich testing pattern is a flavor of integration pattern, which is very rare because there are not a lot of situations that you can do that, and that's something between bottom-up and top-bottom testing when you test two pieces of your system once against the other. In our example, this is perfectly normal. So those are two pipelines. We have the framework pipeline from development to production. We have an application pipeline from development to production, and we test them with each other. So every time we want to test the application, we can test it against the latest trusted version of the framework. And every time we want to build a new framework, we can test it with the latest trusted version of our application, right? And that simplifies a lot of things, but can bring us to this problem of what happens if two changes are incompatible with each other. What happens if my application now relies on something that I need to do in my framework, and I cannot do it before my application changes? And the solution for that will be a good system of triggers. That means that you always should release and test new version of application every time the code is changed, and you always need to test the latest version of the framework every time something is changed in your Docker file. This is how you allow that those those releases will be frequent enough so you will always have the latest framework or the latest application that you can test the other counterpart with it. And with this wonderful animated GIF that we can stare for hours, I'm done. And I think that's time for all of us to go and hear the glorious Java posse that are reunited here at DevOps US. And that's a big deal, at least for me. Thank you very much.